So now let us see the IoT applications, some of the applications. So the smart grid, so this is the first example I'm taking, which is a smart grid. So what is the advantage? So this is one example where you can use such network of smart objects to conserve the resources or to optimize consumption of the resources. And the smart grid is a classic example of am I audible, Keshu?
You are audible.
I'm audible, right? Because I saw your message. That's right. Okay.
No. Please continue. Thank you.
So okay, yeah. So the smart grid is a classic example of Internet of Things. And so if you look at it, it is a huge network encompassing power plants, transmission network, distribution network, substations, and all the way down to the end consumer premises. So it is a huge network, okay. And when implemented, it is expected to save energy, a lot of energy, and use more clean energy resources. So they say you can use clean resources, in ad hoc manner only if you have that kind of smart network, okay. And it can, for example, send requests to reduce the load. That is one of the example. So you can send the instructions down to the consumers to reduce the load, say for example during the peak hours, and then also offer incentives to do so. So it can continuously transmit, for example, variable billing rates and encourage load shifting to non-peak hours. Okay, so which is called the demand response kind of schemes. They're already being implemented in countries like US. Now it is possible only if the utilities can go all the way down to consumers. And typically the way it happens is they send these instructions to either home energy gateway or they send the instructions to the smart meter. And the smart meter or home energy gateway is connected to the appliances at home. Like for example, your air conditioner, washing machine, your refrigerator, your motor, lighting, etc. So if you have programmed your smart meter or home energy gateway to accept such instructions from the utilities, then that gateway or smart meter can instruct your appliances to either switch off or reduce the consumption of the load. So advantage, so what is the advantage of that? So in the particular, say a big metro, if you implement these kind of schemes, then it can reduce the load. Today what happens, at least in Western countries, when there is a load, peak load, they have to fire temporary power plants based on, say, a gas, which are more expensive. Or if there is a demand, consistent demand, then they have to add more power plants. Okay, so all that can be avoided, and you can basically shift the load to non-peak hours by this kind of scheme, and you can incentivize the users for that. Now the smart grid is a network of networks. So in home or in a building, commercial building, you will have local home area networks. Okay, say for example Zigbee home automation or Zigbee smart energy profile kind of network. Okay, which is connected in turn to the larger network. Now either through smart meter or a dedicated home energy gateway. So the smart meter also can work as a gateway or dedicated home energy gateway you can use. So the way, so it becomes like a hybrid. Okay, because the devices which are, the appliances which are at home, okay, you cannot access them over internet. You have to go through the gateway. Okay. Now there are substations, okay, which get connected in that locality. The substations serve the locality. Now each substation may also have a local real-time network of their own, and they may use more reliable kind of network, which is more reliable than what you find on the internet. And again, that network will get connected through gateway to the larger internet. The smart grid is a two-way energy and information transfer network. And this is possible only if we have real-time sensing and smart devices which can take real-time decisions. The smart grid is full of very smart devices, smart sensing, because everywhere across the board, for example, power plants with transmission, okay, all the way to substation and at home, everywhere you will have to take a real-time decisions. All the devices need to be smart, and they need to talk to each other, and they need to sense impending problems and take corrective actions. And there has to be a lot of predictive capability in the smart grid. Only then you can have a smart grid which is a self-healing and reliable kind of grid. Okay. One example of this, for example, sensing system, for example, can detect transformer issues and can take actions. So such systems are available. So a lot of sensors are attached to this transformer, and things like oil temperature and water content in the oil, etc., are measured continuously. And the predictive analytics algorithm inside the system can predict the impending problem and can take action. Now, another aspect of smart grid is, now the smart grid is a huge network and very smart network, so supposed to be. Now it is possible only if you have a well-developed communication standards. So devices can talk to each other. So there are a lot of standards which have been defined, okay, for each aspect. For example, there are different standards for your buildings or homes, and there are different standards inside the substation. And there are different standards, say for example, for communication between smart meter and the utility. Okay, so a lot of standards so that the devices can talk to each other. So this is one example, a good example of IoT. The next example is smart building. Basically, the advantage of such kind of network inside the building is basically human comfort and also safety it can ensure. Now, a typical modern building, you have many appliances, and these appliances are getting smarter and smarter. And they have sophisticated electronics embedded into them. They are also network enabled so that they can talk to each other. And you have a supervisory control system, monitoring system, which can keep an eye on all these things, the entire system, and make sure everything is working fine. Some of the examples which you can see there, like air conditioning, fire safety, access control, video surveillance, lighting, elevators. So many examples are there. Okay. Gas leak detectors, those kind of things. And in a smart building, these systems will interface with each other, forming basically coordinated networks. I just give one use case, okay, so you'll understand the advantage of such network. If, for example, the access control system detects very less occupancy or no occupancy in the office or in the, say, a room, okay, one big room, for example, then it can ask the HVAC system or a lighting system to switch off in that room. Okay, so that will help save the energy and the money also. Okay. Now, if the entire building is sparsely occupied, then it can even switch off one or two elevators to save the energy. If in case of fire, for example, the fire system can ask the access control system to unlock all the doors. Okay, and all these things can happen, without human intervention. If the system is programmed well and it has this built-in intelligence, then the whole system will have its own smartness or intelligence or its own brain, and it can take some actions in these kind of situations. So that is the advantage of this. And you will start seeing, it's already happening, and you will start seeing more and more such kind of smart systems inside the building. An advantage of this is basically it is human comfort, human safety, I said, but also energy conservation. So when all these things work together, you can save also energy and cost. Okay, so this is automotive applications. So things like say intelligent transport system. The intelligent transport systems will have, for example, on a highway, for example, where they are talking about the system where the vehicles will interact with each other. The vehicle can talk to each other, communicate with each other. The sensors along the road will read the traffic situation. We can detect the problems like accidents, etc. The toll collection and those things will be automated. It's already happening. So it is automated. And so the advantage of this kind of system where the things are networked is you can have a much larger traffic density on the same roads. And one example of the smartness where the smart devices is collision avoidance and automatic braking systems, which are available in high-end cars like Mercedes-Benz, where you see the vehicles can detect the impending problems like accidents, which is going to happen, and they can apply the brakes. Okay, so now you can see that these systems are slowly going to mimic a human behavior, and they will start taking certain action in real life without human intervention. And another example of this is, of course, autopilot, what you see in commercial aircrafts. And the same kind of systems are slowly coming to the end users and in the cars. This is another example where you can use it for the tracking behavior, for example. Maybe the retail applications, or I just given an example of car insurance. So you have programs today, like pay-as-you-drive schemes, where car insurance companies, for example, they will charge you based on the driver behavior and driving habits. So the car has a onboard unit which is connected to the internal systems of the car, like say engine control systems or braking systems. They can detect, for example, your braking habits. Okay, so how do you apply the brakes? They can detect your speed. The GPS systems, they can find out your location, they can find out your speed, they can find out your driving behavior, and based on that, they can charge you. So today, for example, people are profiled based on their age, demographics, education, those kind of things, and sometimes even color of the car. Instead of that, it will be more of individual tracking, basically individual behavior that will determine how much car insurance you pay. Another example is retail, for example, where video surveillance and sensors are used to see where the consumers, the customers linger, where they spend more time when they move around. And based on this information, you can redesign your retail layout. Basically, you can optimize your layout for your benefits. Another advantage of this IoT or so-called M2M will be the enhanced situational awareness. So when you have all these sensors, so you see typical Internet of Things, many of these devices will be sensors. Okay, then there will be devices which will read these sensor inputs and act upon that. Okay, they will act upon that. But majority of the devices, the smart objects, so-called smart objects, will be sensors, and they'll be deployed in the field. Okay, and most of these sensors will be wirelessly enabled, so you can deploy them in large quantity and wherever they are. Okay, now when you have such a sensor network deployed in the field, it opens up a lot of opportunities basically, and you can learn a lot about your situation or about that area. So one example is, for example, precision farming and cattle tracking, where the farmers are using, in developed nations, farmers are using a lot of sensors, okay, to understand, say, soil conditions, and where there is no water or no fertilizer, lack of nutrients, those kind of things. Okay, and there are many such applications where enhanced situational awareness can be used to detect the problems, okay, which are going to occur ahead of time, and maybe take a proactive steps to mitigate those risks. Okay. So one example is this precision farming. Okay, it not only avoids problems but also it can improve your yield. Okay. The other example is which I listed here is this aircrafts, for example. So aircraft manufacturers, they are installing the sensors to understand what is the conditions. Okay. So for example, airframe or the internal systems of the aircraft. And these are like wireless kind of sensors which will sense the local environments around them, and so that you can find out if there is a problem. Third example is this video surveillance. So today, if you see, the video surveillance is not like what it was before, where it just used to record what was happening in front of the camera. But you have very sophisticated built-in analytics, video analytics in these cameras, for example. Now, just to give an example, in the Bangalore police, they have installed a lot of cameras in many intersections. And what the cameras do, they keep an eye on the road. And especially when you stop at the signal, if you cross the white line, then the camera will detect the violation. Okay, so they will find out that you have violated the line, which is like a tripwire. So you have gone beyond the line, that white line. Then they will zoom in to your number plate, and they will read the number plate. Okay. Now, and then they will analyze this number plate. Now, the number plate, that in India there is no set standard for number plates, and there are different kinds of vehicles. Like auto rickshaws have number plates somewhere, cars have somewhere, trucks have somewhere. But still, those cameras have the capability to understand what is the vehicle, where is the number plate, zoom into that number plate, read the number, and then interpret the number and find out the details of the owner, okay, and generate the ticket, okay. And then basically, when you get the letter, you can go to the website and see yourself, okay. You will see the picture of your car and the violation and number plate, etc. All these things basically happen, without much human intervention, okay. Maybe except later, but identification of the violation, detection of violation, the number plate reading, and all these things happen without human intervention. So that kind of intelligence. Same thing, for example, another example is say airport. Okay, somebody comes and keeps the objects, keeps his bag and walks away. Today, it will be detected immediately. Okay, cameras are watching everything, and they can find out the left objects immediately. Similarly, if there is a violation of one way, you are not supposed to walk through the door, but if somebody is walking through the door, they can detect. Cameras can read the face, and they can identify the face. Okay, they can identify whose face this is. Okay, so face recognition is there. So that is another example of what you can do with enhanced situational awareness if you have such capabilities. We talked about sensor network. We also talked about a lot of this data analytics that you can use to take decisions. These are some of the examples. Okay, so there, for example, assisted living, okay, or helping old people to live alone, but still you want to monitor them, their conditions and their health continuously. So you basically use the sensors, different kinds of sensors, and on the patient, and you can monitor the health of the patient, and you can do that remotely. Okay. Also, there is a concept of smart dust where in very large quantity you spread sensors in a geographic area. There I given one example which is like water pollution, but it has applications also in, say for example, battlefield defense application, where you basically spread or spray these very small, tiny sensors, and these sensors will monitor the environment where they are in, they are dropped. They will form ad hoc network. They will discover themselves. They will become part of the network. They will have that kind of flexibility, and when they will start communicating, okay, to start routing, so they will have a mesh kind of capability. So those kind of wireless sensors you will see more and more. And one of these features of such wireless sensors is power. So many of these sensors will take power from, say, solar or their environment, wherever they are. Like scavenging, energy scavenging or energy harvesting, as they say. If there is a vibration available, then they will use the vibration to generate energy. If there is a solar available, then they will use solar thermal energy. They will use thermal to generate the power that they need. These are industrial applications. We know that the robots are already part of assembly lines, where they perform many of their activities with automated intervention in the factories, for example. Many more applications, are being conceived, and so these are basically what we are talking about: autonomous systems which perform tasks that humans do today. Okay? And so slowly, machines will take over more and more what humans do. For example, is packaging. Okay, so where packaging, for example, if there is a problem when you print on the package, then you can have video-based system where they can detect even small problems in the print, okay, of the package, and then they can reject those packages. Or in the assembly line, okay, in this example, what you see, sensors and actuators can be used to change the position. So many a times the objects need to come in the proper order. Otherwise, it can cause an assembly jam, okay, and it can cause delays and cost money. So you can use automatic systems using sensors and actuators which avoid such things, and which save basically a cost or the efforts. And more this feedback control, you might have heard this, where you feed back to the controller which is doing some action in real time, and you will have systems where they will start taking such actions. Where, depending on the situation, they will find out what corrections they need to make, what offsets they need to apply, and keep the system in a balanced state. How many of you have seen last week, 2 weeks ago, there was demonstration in the TED by Dr. Vijay Kumar, who is a professor in one of the US college, university, and he demonstrated flying robot. Okay, and it's amazing demonstration, basically. Okay, where he has seen, he has shown what you can do if you have such smart objects, and these are very small robots. Okay, and you can fit them on the palm of your hand. Okay, and so what he has shown in that demo, basically, that swarms of robots coordinate with each other. Okay, and to perform very complex tasks, and you have to see that video to really believe it. Okay, so what kind of things is this thing? So the last example, what they have shown in the demo is they actually play music. They coordinate with each other and they play music. Also, they can fly in the formation, and even if there is the obstacle, they can detect the obstacle, take real-time decisions rapidly, okay, and then work together. And basically, they try to mimic human decision making. Okay, almost feels like a science fiction when you watch the video. So that is a trend, basically. We want to go towards systems which are very, very autonomous. they can work together, okay, and they can do the complex task together. So if you see these robots, individually they are very small, but he has demonstrated that when two such robots work together, they can lift very heavy objects, okay, and they have demonstrated that these robots actually build a structure like a building. Okay, and these robots also have a capability. Okay, they can they have their own sensing. Okay, so if you let them go inside the building, they can scan the environment and they can form. Okay, how this building looks. Okay, like sort of blueprint basically, and they can use this information to navigate later. So all these capabilities you can have in the objects. So what are we aiming for really? Okay, so from the data, we are going towards wisdom. So data is basically measured values, sensed values. Information you can say is like the relationship of measured values with real world parameters. So what part? Then knowledge from the information we put knowledge where we detect and understand patterns basically. So we know the answers like when it happens, how it happens, where it happens. And finally, wisdom, where we know the principles and then we can use these principles. So for example, we know what the do's and don'ts. Okay? We know why something happens. Okay, what happens, those things. So that is the aim.